Okay, we're ready over here. Zach, are you ready? Is it everything functioning? Okay, cool. Please, round of applause for Zach.
All right. So yeah, I'm going to speak a little bit about Module Federation. So a small background on it. I'm actually the guy that created it. So that's always fun. Let's see what the next slide says. Actually stay on track this time. All right. Yeah, so the motivation behind it. For anybody who doesn't know what it is, the idea is quite simple at face value. I want to be able to dynamic import code from a separate Webpack compile. So basically, I want to do code splitting, but I want the chunks from a separate build that was deployed independently. Seems simple enough. The motivation really behind needing something like that was mostly to do with the scale issue. When you're working in a monolith, I'm sure lots of us have seen this. If you're doing NPM package management, I usually call a process like the double deployment. You ship the package, you go to the app, you install the app, you ship the app, and you repeat that multiple times depending on how many apps you have. And that can get quite tedious. So the big things that I really wanted to get out of it from like the business level and from engineering level is autonomy, ability to orchestrate something, dependency sharing in a somewhat efficient manner, and as little UX drawbacks as possible. All right, so as a simple context here, usually Federation is referred to with micro frontends because that's probably one of the most popular implementations. But Module Federation will work with anything that can execute JavaScript. So you can do it with WebAssembly, you can do it on embedded devices. We've done it in cars. We have it running on game consoles that most of you probably own at home. We can obviously do it on servers and on the edge network. So generally a context of it, though, that frames it up is you've got header, sidebar, various pieces of pages that are owned by various teams. You want these teams to be able to move independently. And a big one for me, especially if you've ever managed distributed apps or micro front ends, it's very painful. If you've ever used externals, who's used externals before? All right, and that's, it's a great when it's one or two, but when you've got 50 dependencies across 100 teams, a single point of failure is quite easy to achieve. So the general issue that I'd run into before actually creating the technology was we have native ESM, and that has some web performance issues, though it is getting a little bit better, and import maps has recently come out, so that's quite a nice advancement. But the general thing that I've seen, especially like I work in retail, so performance is really crucial. Native ESM either requires preloading or it's a lot of additional requests. So generally, it's not really great for web performance. The single build is very optimized, but it's very slow. And anything like DLL or externals is a lot of manual work, and we really don't want to have to deal with that. So what we really want to try to get is some kind of a scalable trade-off. I want it to be relatively well optimized, I want it to perform well, and I want to try and remove as much of the thinking from my engineering teams as possible. If they know how to require code, that's really all they need to know. The orchestration and self-formation of the applications, I want that to be Webpack's problem. All right. So this is where Module Federation comes in. So there's a few terms that I've kind of coined to help frame up Federation and the different parts of it. Mostly we will refer to something as a host. A host can really be anything, but the host is usually the thing that executes first on the page, kind of like the wrapper. If you have an app shell, we would call that a host. A remote is usually the thing being consumed. Bidirectional hosts, the idea kind of comes from fractal architecture. It can either consume or be consumed, and pretty much anybody could behave as a host under a bidirectional model. And then we have omnidirectional hosts, which is really, it can be anything at any point, depending on where and how you implement it. So some of the goals that I wanted to achieve for Federation, I really want to, so the main one, I want to import foreign code. I want to be able to do this at runtime. I want to be able to share things dynamically, mostly my vendor code, and I want deployment independence. I also really do want to think about versioning and evergreen dependencies. Sometimes evergreen's really great, but usually when you're dealing with risk, you need some way to still have kind of like a lock file at runtime. So I need some mechanism that'll allow me to do that when I need it. I want some level of redundancy built into it, so if a dependency goes missing, unlike with externals, the application doesn't fall over. I could just requery everybody connected to the network and find, is there any other application that can vend a dependency within the SymVer range of the requirements of the system? If somebody can, I can pull it from every application. The more applications you attach to the network, the higher the redundancy becomes. And I want something that offers a good DX, especially when we're working in kind of the NPM package hell space that we've had to deal with. So the big thing that I really want is it to just work. So everywhere, and I want it to be simple. So let's take a look at what configuring or consuming this looks like. And there's very different ways that you can do this depending on what you need, but we'll go over some of the more basic samples. All right, so on the screen what we've got is pretty much like a host remote pair. I've got application A, application B. I'm exposing button and drop down from one, and then I'm using one of the syntaxes for how to pull in a remote, which is basically just another container. And we're saying application A is going to treat application B as a remote. Both of them are going to share React and React DOM, or whatever else you want. And I don't want multiple copies of React to be loaded, so I can tell it that it needs to be a singleton. That'll ensure that there's only one memory reference for certain things. It's a little tricky to know what should be a singleton and what shouldn't, so the easiest way is anytime that you need to use React context, whatever your framework is. If you're doing something context-based, like a router or state management, generally you only want one of those to be there. So when you're actually using federation, this is pretty much what your engineers would write. If I want the button, I can either dynamic import it, application B button, or I can also statically import it. So this is really useful for things that are not React. When I need hooks, well, that's still React, but when I need hooks, that can't be a promise. If I'm doing middleware or utilities or anything else that it doesn't just work in an async space, the ability to just synchronously require code is extremely helpful. So there are some other alternative configurations, and these are more the configurations that I use day to day. So the most common one that you'll see is just the @ syntax. So the whole idea is on the one side, I have the name of the app that's coming in. I can also re-alias them. So core, the key, could be anything that I want. I could say that I'm going to require it as core inside of the consumer app here, but it's actually going to be a namespace called like bananas on port 9000. I usually keep them consistent so we know what we're talking about, but the names don't really mean anything other than a way to connect to the interface of the other Webpack runtime. Another useful implementation of a remote is the promise new promise syntax. Dima loves that one. He's probably heard me say that 100,000 times in like 6 months. But promise new promise is the whole idea is I can feed a promise in here. I don't actually need to give it a URL. I can give it a promise. I could have a utility function in my browser in the window somewhere, and I could go, resolve a version for it, then get the URL, inject the script, and then resolve the namespace the script comes back as. So this gives you a little bit more dynamic control, and it's not so statically coded. If we're thinking about environments or deployments that go to multiple environments, this is extremely helpful. If you can just detect if you're localhost and point it here, or if you are in localhost and say your meganav is not online, you could catch that and you could just point it to stage, and if you're not on the VPN, then you could point it to production. So now you've got some kind of fallback system that you can build in for whatever your requirements are. The only problem with promise new promise, though, is it does get a little messy, as I've experienced at work, where that little line of code got to be about 500 lines long. And it's a template string, so amazing I have not broken production. So then we get some other deeper concepts. These are not really used that much, at least on users on their own. If you get into this territory, get in touch, and we'll make sure we sort something out for you. But the concept of federation controlling federation is also possible. So what this looks like is I'm going to have a promise, and it's going to connect to another remote entry. That remote entry is going to have loading logic middleware. I'm going to pull that in, execute the factory on it, and then I'm going to tell it what I want, and I'm eventually going to get the injected remote that I'm trying to get out of it. So now I could actually have a separate application that's only job is to orchestrate federation itself. And this can become very deeply nested. So there's a lot of power behind it. But still, promise new promise, It's nice, but be careful with the syntax. So the most recent build out that I've done is around something called delegate modules. I've been very excited for it, and I've wanted it for quite a while. And I had a theory on how to build it, never actually found the time. And then eventually I just snapped one day and was like, well, let's see what's the worst that's going to happen. So delegate modules allow us to use extremely advanced interfaces. This lets us take the glue code from Webpack and move it back into your application. So in a simple way, it's promise new promise, but it's bundled in your app as an actual file. So if you wanted to require launch darkly, you can import launch darkly, connect to the socket, and as long as you resolve a remote entry back to Webpack, it doesn't care what you're doing inside of that. So we use this for quite a couple things, but the biggest use case that I have it for here is this is in a Next.js application, and I have something called the Medusa delegate. So the idea is instead of me passing the @ syntax or some other string primitive in here, I've got a utility function that generates a delegated module. I point it to somewhere local on my file system. And in this case, I can pass metadata that I'm going to consume from that delegate module down the line. So here, home, the token, the environment I'm operating in. And you can also mix and match them. Like checkout could still be static if that's what you wanted. So this is what the delegate module actually looks like on the other end. Again, this is a little bit more intricate, but if you think about the grand scheme of how to actually pull this off outside of Webpack, it would be very ugly and very difficult. So while it looks a little interesting, it is quite powerful. So in this case, Webpack's going to find the glue code on how it connects to another remote. It's finding that it's already in its graph. So it's just finding another module that happened to be bundled into it. And in this case, I'm exporting out the Medusa client, which connects to a SaaS system that we have that's like a central brain of Webpack at runtime and build time. And then I'm pulling things off of using a Webpack variable. We've got resource query. Basically, anytime I put a question mark on the end of something, it turns it into a query string. So now the delegate knows which remote entry Webpack's currently requesting. Otherwise, it'd have to make one for each and hard code the names into it. So this is just a way for me to pull out the information that I want, feed it into Medusa. Medusa responds with a remote entry with a metadata. In there, it includes the base path of the URL. It'll include the version or the hash. I usually use the commit hash on the remote. And then the namespace that I can find it under. I take in this little bit of metadata, I reconstruct it into a pattern I can use, and then at the bottom I call import delegated module. I pass it the global, the URL, and it will return a remote entry container. Webpack sits here and waits until that return happens, because that's a resolving promise. Once it resolves, it continues running. What's nice about this, though, is this whole import delegated module capability all works on Node.js as well. Since this is Next, this works in all environments everywhere. But you can also use this without, say, the delegated part. I can pass a global to any script that I need and a URL, and I can pretty much dynamically load this as the same way as if you're doing document append script. And the code's completely isomorphic because I added all the runtime modules that the browser has. I created server equivalents of those, so it is quite flexible. All right, so when should you actually use module federation? Big thing I would say is don't get sucked in by it if you're learning about it or think it's really cool. Use it within balance. Right tool for the right job is usually what I say. A good way to start, if you've been at some of the talks, you've heard a little bit about this, putting things into a monorepo and getting your code base organized is a good step. And if you get it into a state that I call like federatable, then whether you want to commit into this or not, what you end up with is a very well-organized code base. Modularity, best practices, things that we always try to encourage but are actually kind of hard to get done in practice. Federation kind of creates a forcing function of if you don't have good granular code or good modular code, things could become brittle. So, it gives us a nice reason to actually do it. Something to push back on what's the business value of writing good code. So anyway, when should you actually use it? Big places I use it on are headers, footers, anything global, something that's painful to roll out. Certain features that you have, if you have horizontal feature teams, it gets really tricky to work over each other in deployments. The first place that I rolled this stuff out to was the platform layer, analytics and A/B tests, personalization, things like that. Kind of the fringe areas where there's lower risk, and usually they have the worst performance and the worst integration with your front end. So now I can write actual first-class React components that I can run in there. I can connect them to my Jotai atomic state, and they're able to react with my code base as if the A/B test team was actually writing code in our production code base. But they never have to touch it. And then system migration is also a very good one. If you're trying to move between things, it does create a nice way to kind of transition over a different stack or framework. So in order to make federated components be a bit more stable, how I usually design these and the things that I've been showing you is the polylithic architecture. So there's a couple different ways that you can build out distributed systems. You can do lots of small application design, mount a bunch of little DOM nodes, and they all kind of run independently. My preference is always the polylith. In either regard, what I want to try to do is get the best of micro front end and the best of the monolith and try to reduce the worst of either side. So to make a good micro front end in any regard, I want it to generally be a smart component. It should be able to fetch its own data. It shouldn't have really weird implicit dependencies on the host or the consumer. I should really just be able to pass hints to it, and it knows what I'm trying to ask it to do, and it goes and does more of the lifting on its own. I want to co-locate things well, so it's easy to navigate. I want to make sure it remains loosely coupled, and I really do want to kind of define my federation split points based on the ownership boundaries of the teams. So an example of doing component level ownership. Let's say we have a very simple product display page. Usually it takes a bunch of props and you drill the props all down. This can become brittle because if one of these things change or if you change your underlying feature and they have not updated the implementation, you can get into a state where things could go wrong. So what I usually suggest is something simple like that. The SKU and the color. Whatever it needs to do, it's doing inside of here. So what I'm exposing through federation is pretty much like a 3 export system. I expose just the base component. I'll expose the smart component, which is just like either using, a server-side effect or something suspendable so that it can fetch data on the server. And then I expose the actual underlying data utility. So I still have the composition, but the default export is going to be it just kind of works on its own smart component. To make these things testable, what I usually do is also separate that file out somewhere else. So I don't expose the feature directly. I'll create a file that imports the feature, and then I expose it there. So now if I do need to change the API or deal with anything else, I can do it in this file, and I can unit test this file against the contract separate from having to deal with all the compatibility things in my actual feature code. So it makes a nice kind of separation, and you still get the same desired result. All right, so that's generally federation. Now let's get into Next.js server-side rendering hot reloading. So I have a video here from actually QCon last year when I just barely got this SSR working, and then over the past year I've made it much better, and you'll see some newer videos showing different aspects of it. But generally this is the kind of system architecture that I've got. We have 3 remotes. Checkout is going to be the host in this case. We have a share scope, and that's really where all the shared modules kind of blend into each other and figure out what they're going to do. And you can see the kind of import order here if we expand that out. You can see their independent remote is consumed by home, and home is consumed by checkout. Nav is also consumed by checkout. So that's kind of the tree hierarchy that I've got. All right, so this is an example of pushing an update into production. So I'm going to go in here. I'm going to change this, put some other text on it. And so the big thing here is I don't want to redeploy anything else. So this is 3 remotes down the import chain. I want to ship this one independent remote, and I want anybody who consumes this to automatically update without needing to be re-released, restarted, redeployed. They have no idea anything's happened, and only thing that ever gets shipped is the one repo that needed it. I refresh the page, and that's actually server-side rendered itself. The whole process of going from my machine to production takes about 60 seconds. The last time the other remote was deployed was 13 minutes ago versus that one which was just deployed, just to prove that there was no double deployment. And in there you can see in the HTML it actually server-side rendered the update. All right, so now this is where we get into something a bit more interesting that we just got a good release out for. Medusa, like I said a bit before, is kind of a control system for this. So scaling up these distributed systems gets a little tricky. How do you know what version you're at? How do you roll certain things back? How do you even see how your software is being consumed across an organization? If you have 100 teams 1,000 repositories, it's going to be very difficult to understand how your software is consumed and who you're actually vending it to. And this is kind of where Medusa comes into the fold. So Webpack sends all of its build graph data to Medusa. Medusa ingests all the Webpack graphs, and it starts to draw the connections about how these things are consumed. So now I can see here are my apps. I can see what they expose on either end. If I drill into it, I can actually see the node view of it. So shell, I can see shell, it depends on header, checkout, and story page. And if I jump into that node, I can now see what it depends on. So I know that checkout depends on home, and I can see that header is used by app. Home is used by the index page, story is used by the dynamic slug root, and this thing is vending out title and checkout to shell and the home app. And I can also see which versions I've pinned the application to, or the commit hashes that are currently in this environment running. And all of this is done in real time. So the second a build hits Medusa, the entire system redraws exactly what's going on. So here's a demonstration of doing kind of the hot reloading thing that I did, but utilizing Medusa to do this. So I'm going to go into Medusa, I'm going to go to one of my remotes. Here's just some of the general information that we have, what dependencies it's sharing, all the versions that are released of home. I'm going to change home from red. I'm going to switch it to green. Okay, yeah, so now when I reload this page, refresh it a couple times as I wait for Medusa to propagate everything out to the edge, and there we go. So now this is a separate pull request. This is a different build with the green. It's not a CSS trick or anything. The header is now a separate code base, and that's a branch sitting in Versal somewhere else. But I didn't have to redeploy any part of my stack, and it took about 4 seconds to update production. So you can wire this thing up, and that's essentially what your life cycle looks like. You can roll everything back, roll it forward, and generally your time to reflection in production is 2 to 4 seconds. Server side, client side, anywhere that you want, and you've got that safety of like the lock file system. So you know that it's not going to change randomly on you on the fly. All right, so this is something new that we've been working on. I'll try to release it when I get back to the United States, but we've recently been able to get Netlify and module federation working at the edge. So no more node lambdas, no more infrastructure to manage. I have one Netlify edge worker, and I can deploy pretty much an unlimited number of code bases to this because Federation's main idea is to separate the compute primitive from the file system. So all I need is a CPU on the internet, and I have code somewhere else on the internet, and I can find any CPU at random and tell it to become any piece of software inside of my company. So in this case, we're doing it on the edge. So this is a very simple React streamed example. Again, not pretty, just set it up to prove the concept's possible because we had some challenges for a few years. But the whole idea is you can see the host was rendered at, there's a date stamp, it's using the current location of when I took the screenshot, and then you can see that's the second worker which is getting pulled in through Federation, and you can see that the timestamps on the two are different. So it's not like they both executed at once, but I can actually see when Webpack pulled this thing in and kept it inside of its runtime. And the nice thing with doing this on the edge as well is it's using streaming. So if one of the remotes takes a little while to get back to the edge worker, it doesn't matter, I'm already sending responses back. So my usual response time on a federated edge worker is around 150 milliseconds or so, up to 300 milliseconds for a full response. So anyway, so that's kind of like the federation side of things. Since this has been building up a little bit, and I want to speak a tiny bit about like the future state of where things are going, we all know that Webpack has been real good to us, but it's a little bit complicated, and I know that the speed has become a bit of a challenge. That started to make us look at other tools where you often end up sacrificing the build speed for, or the flexibility for better build speed. RSPack is basically Rust, is Webpack directly ported into Rust, one-for-one API. So all the plugins work, all the loaders work. For the most part, you change one word in your command line and your application should run just fine. So the speed difference is quite substantial, considering that RSPack was released less than 3 weeks ago and has no caching system built into it. So we're building 50,000 modules in 3.7 seconds, and that is it's pretty much as slow as it can be designed to be in Rust. So it's only going to get quicker, but that's still a significant speed improvement. Something that's really great that's just come up. We actually figured it out. We solved it today, just an hour or two before this talk. So I'm very happy to be able to announce this. I know we've had a lot of developers looking forward to it. And that is, RSPack now works with Angular as of a couple hours ago. So if you have those big Angular builds, and I would do a big shout out to Valor Software, who was running up and down the hallway all day today, busy patching this thing in, working with a bunch of teams in the open source to land this. But this is a really fantastic progression, especially with Angular looking at shifting over to Vite or ES build. While that might be great, it also is very difficult for users who depend on the power of Webpack. So a nice drop-in replacement, and we're not really now coupled to the Angular CLI or its future or what they do. So to give you an idea of the speed of this thing, and again, remember, this is highly optimized, just got working. The Webpack build of this is 7.7 seconds on a cold build with Angular via Webpack and ES build. In RSPack, the compile time for fully optimized production build is 2.3 seconds. And this is, again, a very small application. When you start to scale this up, we usually see a significant increase in the build performance as Rust heats up. We're really excited about this, so I've put Valor's tag there, and we're going to tweet something out. If you do want to help support the adoption and the community growing in awareness about a new compiler tool, we'd love if you went on Twitter and helped us boost it with a retweet. But yeah, I'm very excited for this. This conference has been really fantastic, kind of meet out with some other members of the community. Just the other day, we ended up working with BitDev, and we got a kind of very clumsy implementation working, but Bit's build time on this component went from 90 seconds to start the dev server to, I think it was 2.1 seconds to do a fully optimized production build. And that was a... And cool, so that kind of wraps up the big things I wanted to speak about. Things that we do have in the work is, of course, federation. What would RSPack be without federation? So federation is in the works. Edge worker support, we're going to drop that. Delegate modules, I'm going to work on isolating that out, so if you need that power, you can get it. Right now, I've kind of tied it to my next implementations. Angular support, I think you've already seen that. And making Medusa available to non-Webpack-oriented front ends. If you're using single SPA or you're using import maps or pretty much any distributed system, we want to be able to pull Medusa's intelligence forward. The last thing that we've been working on, which hopefully will help on the infrastructure side, is we've been working with AWS on a service discovery system. The idea is you'll be able to write a JSON schema that's standardized across all of the major micro front-end builders like single SPA, me, I think Parial as well. But the idea is going to be that this JSON file is what Webpack will reference at compile time to configure federation. At runtime, it can reference that as well. And you can post that JSON file to AWS, and it'll automatically stand up S3, Lambdas, Route 53, pretty much everything that you need to scaffold infrastructure. It'll set up a kind of production blessed by AWS thing from one single source of truth. All right. So I know it went a little over time, so I don't know if we have time for questions, but I will be around, so feel free. I know how to get through a lot of content quickly, so if there are any questions and you want to speak to me, I don't bite.